Yeah, in section 2.5, we're going to be discussing, first off, x-intercepts and y-intercepts. An x-intercept is simply where a line or any graph crosses the x-axis. And we remind you that the x-axis is always your horizontal axis. And notice with the green line, we cross the x-axis here, and I want to point something out about the actual coordinates there. We have the point 1, 2, 3, 4. -4 is the x-intercept, or the point -4 is 0. For the blue line, we see right here, -3, 0. And for the pink line, we see that 0, 0 is the x-intercept. Now let's move on to y-intercept. Y-intercept, reminder, we have the y-axis is your vertical axis. A y-intercept is where a line or graph crosses the y-axis. We see here that this green line crosses the y-axis at the point 0, 2. The pink line crosses also at the point 0, 0, and the blue line crosses at the point 1, 2, 3, 4, 5, 6, 7, 0, -7. And we say all that to say this. For an x-intercept, notice our three x-intercepts here. -4, 0, -3, 0, and 0, 0. We need to know that anywhere we have an x-intercept, our y value at that point will always be 0. And right flip-flop backwards, our y-intercepts. We notice the point 0, 2, 0, 0, and 0, -7. So at a y-intercept, we want to put this in our notes, at a y-intercept, your x value will always be 0, and that's going to be very important to us in these next few problems. If we were given an equation, such as 2x plus 5y equals 20, and we're asked to find the x and y intercepts here, we can do so without actually graphing this equation by remembering what I just told you. When finding an x-intercept, I want to remind you that at an x-intercept, your y value is always equal to 0. And when finding a y-intercept, I want to remind you that your x value will always be 0. So what we're going to do in order to find an x-intercept, we're going to take our equation, 2x plus 5, and instead of y, we're going to put a 0 in, equals 20. So we have 2x plus 5 times 0, which we know 5 times 0 will be 0, and 2x plus 0, that term is simply gone. And we're left with 2x equals 20. When we divide by 2, we're left with x is equal to 10. So we have an x-intercept of 10. Let's do the exact same thing to find our y-intercept. We'll take our reminder that x is 0. We'll take our equation, and instead of 2x, we'll put 2 times 0. We'll plug in 0 for x. 2x plus 5y equals 20. Since 2 times 0 is 0, and 0 and 5y will give you 5y, that term will simply leave, leaving us with 5y equals 20. Dividing by 5 yields y is equal to 4. So we have an x-intercept for this equation. Our line, this is a line, our linear function, would have an x-intercept of 10, which means it crosses the x-axis at 10, and it would cross the y-axis at 4. Or if we wanted those as points, reminder that would be the point 10, 0, because again, we did plug in 0 for y, and the point 0, 4. And let's go a step further with this problem. Something else we could actually do, we could actually use this x-intercept and y-intercept to graph this linear function. And again, I want to remind you, the reason we know this is a linear function is notice we have x and y, neither one of them are in denominators. There's no fractions here, the x's are in numerators, and both of them are to the first power. Anytime you have this situation, you will have a line. And anytime you have a line, if you've got 2 points, which we do here, then really you've got a graph. And what we're going to do, let's actually try to graph this using simply those x-intercept and y-intercept. There's me some graph paper. And what I'm going to do here, I'm not going to do a complete graph. I'm just going to get a starting point and then just count from there. There's my origin, my 0, 0. And I know that my function had an x-intercept at 10, 0. So we can plot that point. Here's my origin, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0 is where my line crosses the x-axis, which if extended it on further, that would be where it crosses the x-axis. And we're going to cross the y-axis at 0, 1, 2, 3, 4. So we see that with these 2 points, we got we've got a picture of what our line's going to look like. And we can take and we can connect these 2 points. If we wanted to, we could extend it on a little bit further. And that would be the graph of our linear equation. And we actually found that graph without having to plug any values in except for 0 for x and 0 for y. Now next let's look at the linear function y equals 4x. And we're going to have a little bit of a problem here. Let me get some graph paper ready. And again, to check your x-intercept and y-intercept, to find x-intercept, all we've got to do is take and plug in 0 for y. So we plug in 0 for y, it gives me the equation 0 equals 4x. To solve that, we divide by 4, and we get the value of x equals 0. If we plug in 0 for y, 0 for x to find our y-intercept, we now have y equals 4 times 0, which is 0. And we see that we have both the same x-intercept and y-intercept, which is always going to be the case. Anytime that you have an x-intercept of 0, it's going to be kind of obvious that your y-intercept would also be 0. Anytime you run into this, you're going to need another point on your graph. So what we can do, take any x value, let's find something simple, such as 1, plug that in for our x the same way we would do with our t-tables. And with an x value of 1, 4 times 1 is 4, we have a y value of 4. X value of 1 yields a y value of 4, and that would give us enough points to actually graph that equation. Because once again, in order to graph a linear equation, we only need 2 points. So that would be sufficient there to graph our linear equation. Okay, next up we're going to see actually another method of graphing linear equations. And that method goes back to the previous section where we talked about slope-intercept form. Where if you have a function in slope-intercept form, it's a function of this form. F of x, or y, is equal to mx plus b, where m is your slope value and b is your y-intercept, which we just discussed what a y-intercept was again. So anytime we have a function written in this form, which we see here, y equals 3/2 x plus 1 is in that form. The number that's in front of your x will always be your slope, which in this case is 3/2. The number being added, subtracted, which is your b, will always be your y-intercept. So we can actually, and this will be much quicker and easier to graph, we can actually use this information to graph this linear function without making a t-table. We start with our intercept, or y-intercept. We know that y equals 3/2 x plus 1 will always cross our y-axis at positive 1. So here's our y-axis, and I know that my line is going to cross at positive 1. Again, we remind you, you will always start here. Start with your y-intercept. We also know that our line has a slope of positive 3/2, and I want to remind you that slope is equal to rise over run. And when we're given a fraction, we can actually identify a rise, which is on top, and a run, which is on bottom. And what this is, this ratio tells us that for every 3 units, or every 3 boxes that our line rises, it's going to run twice. So what we can do, and make sure, here's a mistake that I commonly see, make sure you start at this point that you've already got, because this point is on your line. For every 3 boxes that your line's going to rise, your line will also run 2 boxes. And you can do it again for every 3 boxes your line's going to rise, your line will also run 2 boxes. Another something you can do here, a slope of 3/2. Let me remind you of some basic algebra. A negative divided by a negative is equal to a positive. So therefore, positive 3/2 is also equal to negative 3/2. And a negative rise is actually means we're traveling down, and a negative run means we're traveling to the left. So not only can we rise 3 and run 2, but from that same dot, or you can look at it from here, from this dot we could also get down 3 and left 2. And we can continue doing that same pattern to achieve, to achieve other points that are going to be on our line. And that gives us a really easy way to graph these linear functions. Rather than making a t-table for it each time, we could just do that. Use our slope and intercept so that we can get that same function, or we can get that same graph. Now, had we did the t-table, as we did in previous chapters, and we plugged in values 0, 1, -1, we could see that plugging these in, just show you, when we plug in 0, you can plug it in up here, you're going to get 1. I'll do these for you. When you plug in 1, you're going to get, I believe it's 2.5. And if I plug in -1, I'm going to get negative 0.5. And I just want to show you that these same points, we would have got the same line by graphing it the other way. If I plug in 0, I get 1, there that point is. If I plug in 1, I get the value of 2.5, which is there. If I plug in -1, I get a value of negative 0.5. So we would actually achieve the same line. It's just a little bit easier sometimes to graph the slope-intercept form. Okay, let's graph one more in slope-intercept form here. Graphing the equation y equals -5/3 x minus 4. Reminder that any number that's in front, when we're in this form, y equals, any number in front of x is our slope. The number being added or subtracted is our y-intercept. When graphing, we always start with that y-intercept, which is -4. That means our line's going to cross the y-axis at -4. And from there, let me show you a trick here. We have a slope of -5/3. When you're dealing with a negative fraction, that negative can be placed on top, it can be placed on bottom, or it can be placed out front. Not in two places at the same time when it's negative. It's either on top, bottom, or out front. So as we're graphing this, let me show you. We have a rise of -5, and we have a run of 3. Now, if we work it in that way, rise -5, that's actually going to bring us off our graph down here. So what I'm going to do instead of -5/3, I'm going to change that to a 5 over -3. I'm going to put it on bottom. So now I've got a run of 5, a rise of 5 and a run of -3, which can be achieved. If I rise 5, 1, 2, 3, 4, 5, and I run -3 by coming to the left 3, that will fit on my graph. Rise 1, 2, 3, 4, 5, and run -3. And there we see a picture of y equals -5/3 x minus 4. And we connect my dots here. Because again, my line is infinite. And it continues forever in both directions. Okay, next up we're going to be graphing horizontal and vertical lines. And this is actually one of the easier things in this whole chapter. Graphing the equation y equals 2. Now let's look at this first off as a t-table, xy. What this equation tells us, notice there's no x value in this equation. All we have is a y value, y is equal to 2. So it's kind of difficult to think about how are we going to plug our x values in. Let's choose a couple, -2, -1, 0, 1 maybe. And what this equation tells us, if there's no x here, is that no matter what our x value is, this is true. Y is equal to 2. So if x is -2, y equals 2. If x is -1, y equals 2. If x is 0 or 1, y is equal to 2. Y always equals 2. Or if it was y equals 3 or y equals 4, y would always equal 3, y would always equal 4. When we plot these points, we see that what we actually have is a horizontal line. And anytime we have equations of this form, y equals a number, y equals 3, 4, 5, whatever, we will always have a horizontal line. And you can think of it like this. That horizontal line will always cross your y-axis at that number. So this is actually your y-intercept. And here's another way of thinking about it. Since there's no x's there, we can also write this equation as y equals 0 x's plus 2. And we see that this would be, talking about slope-intercept form, this would be an equation in slope-intercept form that has a slope of 0. And if you don't remember from previous sections, anytime we have a slope of 0, that means we have a horizontal line. And we have a y-intercept of positive 2. Next up, let's work let's graph an equation of the form x equals -3. And when looking at a t-table, you've got to be a little bit careful about what to choose because x is always equal to -3. So no matter what y is, if x was -3, y could be 4. If x is -3, y could be 2. No matter what if you plugged in y values, no matter what you chose for y, this is always true. X is always -3. So if y is 1, x is -3. If y is 0, x is -3. If y is 4, x is -3. And anytime you have an equation of this form, you actually have a vertical line. So anytime you have an x equals a number, this is not going to be a linear function. It is not a function because you have points above points. It has a slope that is undefined. But anytime you're asked to graph an equation of the form x equals a number, that graph will always be a vertical line. Okay, next up we're going to be talking about parallel and perpendicular lines. And you probably remember this from previous courses. Parallel lines are two lines that extend forever in the same plane. They can't be in different planes. But two lines that are in the same plane that extend forever and would never cross. Now let's look at a different something different about parallel lines you might not have known before. Let's look at their slopes. Again, slope is the measure of how slanted a line is, and these three lines appear. If you actually find the slopes, you'll be able to confirm it. This has a slope of 1/2, but they appear to have the same slope. This also has a slope of 1/2, and this would also have a slope of 1/2. So therefore, what we can say about parallel lines have the same slope. So if two lines have the same slope, they will always be parallel. Now let's look at perpendicular lines. Okay, perpendicular lines. Perpendicular lines are two lines that, as they cross, we see there's something special about their intersection. They cross to form four right angles. There's also a special relationship between the slopes of perpendicular lines. If you find the slope of our blue line, we see that this slope is equal to, we take any two lattice points, we rise one, run two, so this has a slope of 1/2. And our second line, when finding the slope, actually has a slant of, notice it goes down. From one point to the next, it goes down 2 and over 1, so this slope would actually be -2 over 1. So we have +1 over 2 and -2 over 1, which is evident of the relationship that we're going to have between perpendicular lines. The slopes will always be opposite, meaning that one will be positive and one will be negative in all cases, reciprocals. And when we say reciprocals, that means flips of each other. 1 over 2, 2 over 1. Now we do have to be careful of the case that we have horizontal and vertical lines. We know that all horizontal and vertical lines are going to be perpendicular, but the slopes are a little bit different. Horizontal line always has a slope of 0, and a vertical line would always have a slope that is undefined. So that would also be a case of perpendicular lines. But some examples of what perpendicular slopes would look like. Let's say that one line would have a slope of 2/3. The line that would be perpendicular to that line would have a slope of negative, since this one's positive, and 3 over 2. So those two slopes would be perpendicular. A slope of 4 would be perpendicular to a slope of negative, and to flip that, you're going to need a bottom, so put a 1 on bottom, 1 over 4. So two slopes, in order to be perpendicular, must be opposites of each other, and they must be reciprocals. Okay, the next problem asks us to determine if these two lines are parallel or perpendicular or neither. And the way that we're going to find that out is by looking at the slopes. Now, neither one of these are in what's called slope-intercept form. In slope-intercept form, reminder that y is by itself. Then you have some number, or it could possibly be 1 there, some number times x, and then either plus or minus some number, which is your y-intercept. I do want to remind you, though, that b could be 0. So if you don't have a b out there, it's going to have a y-intercept of the origin. It's going to cross the y-axis in the origin. So what we're going to do, we're going to take each of these equations. Our first one being y plus 4 equals 3x, and we're going to try to get them in this form. And I remind you, we have 3 terms here, and all I'm going to do is take this term here and move it to the end. Anytime you move a term across the equal sign, it changes its sign. So therefore, we now have y equals, leave our 3x first, and 4 will turn into -4. So we see here that we have a line that has a slope of 3 and a y-intercept of -4. The second equation, 4x minus y equals -7. Now there's 2 different ways that you can solve this. I'm going to start with a harder way. We want to get y by itself, so I'm going to move my 4x term over first. And I'm actually going to list that 4x before my -7, because again, my x term is normally listed first. So 4x, when moved across the equal sign, becomes -4x, and 7 stays negative. But y is still not by itself. It's got a number out in front of it, and that number is understood to be a 1, -1. So in order to get rid of that -1, now we have to take it to the other side since it's being multiplied. We will divide everything by -1, which leaves us with the equation y equals, because that cancels out, negative divided by negative is a positive 4x, negative divided by negative is a positive 7. Now another way of working that, which by the way, that has a slope of 4. Another way of moving that, let me show you this. Something that I do, I notice that I have a negative y here. Let me rewrite this. 4x minus y equals -7. What I'll do is if I have a negative y and I need to get it by itself, I will actually pull a double switch here. I'm going to take this negative y to the right side because I know anytime I move a negative term to the other side, it's going to become a positive. And at the exact same time, I'm going to take my -7 and move it to the left side. So what I'll have now, my 4x, which did not move, remains 4x. -7 when moved over here will become a positive 7 equals minus y when moved over there is going to become a positive y. And 4x plus 7 equals y is the exact same thing as y equals 4x plus 7. Now again, we're asked to determine if this is parallel, perpendicular, or neither. My first equation has a slope of 3. My second equation has a slope of 4. So this equation, or these two equations, are neither parallel nor perpendicular because if they were parallel, those slopes would be the same. Okay, next up, let's determine if y equals 4x plus 5 and 3y minus 12x equals 6 are parallel, perpendicular, or neither. Again, first step, make sure they're both in slope-intercept form, which this one is. The second one, to get in slope-intercept form, we're moving 12x over. We now have 3y equals, let's put it in front of the 6, and that 6 is positive. So we have 3y equals 12x plus 6. To get rid of the 3, we're going to divide everything by 3. We now have y equals 4x plus 2. Notice that both equations have a slope of 4. First one has a y-intercept of 5, and the second one has a y-intercept of 2, which that is important. In order to be parallel, they need to have different y-intercepts. So therefore, since they have the same slope, different y-intercepts, these two lines would be parallel. Okay, next problem, let's do the exact same thing. And we've got to be careful on this one. Really, all we have to do is get rid of our numbers out in front of the y. So in order to do that, on our first, we're dividing everything by 3. So now we have y equals 2 divided by 3, or 2/3 x, plus 15 divided by 3 is 5. Second one, divide everything by 2. Get rid of that 2. We have y equals 3/2 x, minus 3. And again, these are not parallel because they don't have the same slopes. They have similar slopes. And also, they're not perpendicular for this reason. The slope of the first one is 2/3. The slope of the second one is 3/2. In order to be perpendicular, the slopes not only have to be reciprocals, which these are, but they also have to be opposites. So therefore, since both are positive here, this would neither be parallel nor perpendicular. Okay, last problem. Again, let's decide whether these are parallel, perpendicular, or neither. The first problem, in order to get rid of the 5, is all we're going to have to do is let's divide everything by 5. We now have y equals 4/5 x plus 2. So we have a slope of positive 4/5. Second one, in order to get y by itself, let's move our x term. We now have a 4y equals 5x turns into -5x. The 4 was a positive, so we're going to put plus 4. In order to get rid of the 4, we're going to divide everything by 4, which gives us an equation of y equals -5/4 x plus 1. So we have a slope of -5/4. Since the slopes are opposites, one being positive, one being negative, and the slopes are also reciprocals, 4/5 and 5/4, they're flips of each other, these two lines would actually be perpendicular.